Today, we're going to be calculating permutations and combinations. Permutations and combinations are ways to figure out how many ways there are to do something, to put things into groups. And for one of them, order matters, and for the other, it doesn't. Permutation is the detailed and finicky one. So order matters with permutation. For example, if you had one of these 4-digit locks, and let's say the number that opens this lock is 1234. That is not the same as 4321. If I put in a 4321, this lock wouldn't open. That is an example of a permutation, and really combination locks should be called permutation locks because that's what's going on here. With a combination, you have a situation where order doesn't matter. So let's say you have a bunch of kids and you need to put them into groups of 3. There are a certain number of ways you can do that, mixes and matches of the kids, but it doesn't matter what order they stand in once they're in those groups. So that's the basic difference between a permutation and a combination. The formulas here on the right, you can see you have this little n, and for a permutation you have a big P and then a little r. Same thing for the combination, except you have a big C. The n means the total size of the group, and the r means how many you're choosing or picking out of that group. Let me show you an example of how to calculate one. So this problem says evaluate 8p5 and 9c1. So what this means is we're asking how many permutations are there when you choose 5 things out of a group of 8 and that the order matters. To do this, you take the total number of things, that's our 8, and you take the factorial of that and put it over the factorial of the total number minus the amount you're choosing. So this would mean, in this case, 8 factorial on top. And on the bottom, n minus r, so 8 minus 5, it would be 3 factorial. When you're calculating these, it's good to write them out until you get really used to it, and maybe you can do some of this in your head. But 8 factorial is, of course, 8 times 7 times 6 times 5 times 4 times 3 times 2, and technically times 1, but, you know, the times 1 doesn't really change anything. And then 3 factorial, I'll write it down here, is 3 times 2 times 1. What you're going to see is that this and this will cancel. And you're going to get a lot of cancellation with these permutations and combinations, so be looking for that. So now we have 8 times 7 times 6 times 5 times 4, and at that point you'll probably want to get out your calculator. 8 times 7 times 6 times 5 times 4, and I am getting 6,720. Permutations tend to be bigger because when the order matters, there are a lot more ways to put things together. Let's try this combination. You have 9 things. You're going to choose one thing out of that 9. So in the combination formula, the total number factorial goes on top, just like in the permutation one. And on the bottom, we have n minus r factorial times r factorial. Well, n minus r, 9 minus 1, is 8, so that's 8 factorial. And r factorial, well, that's just 1 factorial. That's not really going to change anything. Let's look at what we get when we do this one. We've got 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's over 8 factorial, so 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 factorial, which is just another times 1. Now all of this is going to cancel. And then this times 1, well, it doesn't really matter. What we end up with is 9 over 1, or just 9. And if you think about that, what this problem is asking is, let's say you have 9 different kids, and you want to know how many ways there are to pick one of those kids. Well, there are 9 kids. You could pick one kid or the other kid or the other kid, so there are 9 different ways to pick one kid out of a group of 9. So that is a little bit of work with computing permutations and combinations.